Hello everyone. In today's video, I will be going over this review packet for our first test over absolute value and piecewise functions. Number 1, circle all statements that are true. So we have 6 problems here, and we need to circle any of them that create true statements. A lot of students are trying to solve and move things around in these equations, but that's actually not at all what you have to do. Doing so won't necessarily mess up the problem, but really what you need to do is just simplify the left side down to one number and see if it's equal to the right side. So let's do that. I'm going to draw my line, but I'm not moving anything around the equal sign. 4 plus the absolute value of negative 1. The absolute value of negative 1 becomes a positive 1, so I just have 4 plus 1 equals 3. And hopefully you can see that is not true, because 5 does not equal 3. So, A is not a true statement, so we're not going to circle it. B, 18 minus the absolute value of 20 is 20 equals negative 2. 18 minus 20 is negative 2. And as you can see, those are equal. That statement works. So we are going to circle B. C. Here we have absolute value around the entire thing, and then inside we have 6 minus 8 times negative 1. Remember your order of operations here. This is important. We have to do the multiplication first. Negative 8 times negative 1 is a positive 8. And then we have 6 plus 8, and that's supposed to equal 2. 6 plus 8 is 14, equal to 2. And then hopefully at this point, regardless of what happens with the absolute value, these are not equal. So C does not work. D, we have negative the absolute value of negative 9 equal to 9. So let's take out the absolute value first. The absolute value of negative 9 is positive 9. Now this negative is still outside of here. So if you want to think of it like this at first, you can. Equals 9. And so then that gives me negative 9 equals 9, which is not correct. It's not true. So D doesn't work. E, absolute value of 9 is 9. Absolute value of negative 7 is a positive 7 equals 2. 9 plus 7 equals 16. And 16 does not equal 2. So E doesn't work. Lastly, let's try out F. 7 minus negative 8. Sorry, 7 minus the absolute value of negative 8. The absolute value of negative 8 becomes a positive 8. So now I have 7 minus just that 8 equals negative 1. You don't have to use the parentheses if you don't want to. I just think that 8 kind of emphasizes it when you put parentheses around it, so you know this 8 here came out of this. 7 minus 8 is negative 1. And we have negative 1 on both sides, so this one actually works. So the two true statements of these 6 are B and F. Number 2. X equals 2 and x equals negative 3 is the solution for which equation? So what you want to do is you want to figure out which of these equations these two values both work for. You could do this one of two ways. You could solve all 3 of these individually until you find the correct one, or this is just a general test-taking trick with math if you have multiple choice and you have answer choices. If they give you what the answers are, you can plug them into the equation until you find what you want. So we want to make sure that 2 and negative 3 work. So let's just do the check that we do at the end of our problems where we check our numbers. That's what we're going to do here. So we'll first do it for 2x plus 1 equals 5. So let's check x equals 2. We have 2 times 2 plus 1 equals 5. 2 times 2 is 4 plus 1 equals 5. 4 plus 1 is 5. Absolute value of 5 is 5, so 5 equals 5. Yes. X equals 2 works. Now they both have to work. If one works and the other doesn't, then that's not it. X equals negative 3. 2 times negative 3 plus 1 equals 5. 2 times negative 3 is negative 6 plus 1 equals 5. Negative 6 plus 1 is negative 5. And lastly, the absolute value of negative 5 is still a positive 5, so 5 equals 5. This works as well. That means the first equation is my answer. Now obviously this could have failed, so I would have had to repeat this process with B or C until I found the correct one. So obviously it's not always going to be the first one. 3 and 4, here we have some absolute value equations we have to solve. Here we have negative 4 times the absolute value of x plus 12 equals 36. So we have our absolute value problem we need to solve for x. That's the end goal. I want to just remind you what these steps are to these problems. First thing you want to do is isolate the absolute value, get it by itself. Once you've done that, you will make two equations. Then you will solve those equations. Lastly, you will check your answers. So that's the process we're going to follow. First things first, isolate the absolute value. If we look at our problem, this has not been done for us yet. The absolute value is not by itself. We have to get rid of that negative 4. Reminder, this negative 4 that's outside of the absolute value, we treat this as multiplication. So if we want to remove it, we'll have to divide it off. This cancels. X plus 12 equals 36 divided by negative 4 is a negative 9. We've isolated the absolute value. Now let's make two equations. The first equation is the same, except I drop the absolute value. X plus 12 equals 9, negative 9. The second equation, x plus 12, equals, change the sign. This changes to a positive 9. And now we solve. Same step on both equations. To get x by itself, we subtract by 12. Come do that in a sec. X equals negative 21. Subtract 12. X equals negative 3. So now let's try our solutions. Remember, you have to check your answers. You can't just assume that they're correct. So let's do that. And when you check, you have two options here. You can plug it into the original, or you can plug it into the equation that you had right before you split it off. Just make sure there's absolute values in it. So for negative 21, just going to check it over here. Absolute value of negative 21 plus 12 equals negative 9. Negative 21 plus 12 is negative 9 equals negative 9. Absolute value of negative 9 turns it into a positive 9, and the right side still negative. This does not work. So x equals negative 21 is not a solution. Now let's repeat that for x equals negative 3. Negative 3 plus 12, absolute value, equals negative 9. Negative 3 plus 12 is positive 9, equals negative 9. Absolute value of 9 is still 9. And once again, you can see that these are not equal. So x equals negative 3 also doesn't work. This means we have a no solution problem. Reminder, please box or circle your answers once you're done, especially on your test. It will be much appreciated. Back to the problem. There's a way you could have found no solution without doing this work, and that's by noticing that right before we split the equations up, notice that this was equal to a negative. We can never get a negative number out of the absolute value, so this is not possible. Here's the thing. A lot of students like that trick, but they pretty much always misuse it. So, to avoid misusing it, I know it's more work, I recommend you still do the work, even if you think it's no solution. That way, in case you're wrong on that, you won't miss any points. Huge recommendation there. Number 4. Negative 2 times the absolute value of 3x minus 2 plus 8 equals negative 6. Again, step 1 is to isolate the absolute value. This has not been done yet, so let's do that. Subtract 8 on both sides. Negative 2 times the absolute value of 3x minus 2 equals negative 6 minus 8 is negative 14. Divide by negative 2. Absolute value of 3x minus 2 equals 7. Now I've isolated my absolute value, so I can make my two equations. First one I've written just the same. 3x minus 2 equals 7. And 3x minus 2 equals negative 7. Change the sign on it. Now I solve. Solving for x, I add 2 to both sides. 3x equals 9. Divide off the 3. X equals 3. And solving here, same steps. Add 2 over. 3x equals negative 5. Divide by 3. X equals negative 5/3. For those of you who prefer decimals, this actually will not be a good number to have a decimal for because this is going to be a repeating decimal. So I'm going to leave it as a fraction. Now, last but not least, we have to check our work. We can't just leave it and hope it works out. And I might run out of room here, so I might have to use a post-it note to kind of extend the space. When I'm checking it, I plug it back in to right before the split or into the original. Right before the split is better because there's less stuff here to work with. So we have 3 times 3 minus 2 equals 7. 3 times 3 is 9 minus 2 equals 7. Absolute value of 9 minus 2 is 7 equals 7. Absolute value 7 is definitely itself. So this one works. Now let's try negative 5/3. 3 times negative 5/3 minus 2 equals 7. Simplifying. With the fractions, you can do this as 3 over 1 and multiply straight across. 3 times negative 5 is negative 15 over 3. Negative 15 over 3 is negative 5. Minus 2 equals 7. Absolute value of negative 5 minus 2 is negative 7 equals 7. And the absolute value of negative 7 is just 7. So it's 7 equals 7, which does work out. So both of these are correct answers. So my answers are x equals 3 and negative 5/3. You don't have to write it out with the commas if you don't want to. You can box them up in their places. I just thought it would look neater to put it up there. Next page. 2 more of these. We have absolute value of 4w minus 1 equals 5w plus 37. First step is to isolate the absolute value. And that has already been done for us. So now we're going to make our two equations. 4w minus 1, drop the absolute values, equals 5w plus 37. And then for our second equation, we have 4w minus 1 equals, be careful here, when we make this side negative, it applies to everything on that side, not just the first term. So we're going to make both of these a minus. Minus 5w minus 37. Again, if you need to take the extra step to put a negative in front of it and then keep the original in parentheses, that way you can distribute the negative 1 inside, you can do that. You'll still get the same thing. Now let's solve. 4w and 5w, I'm going to move the smaller one. Subtract 4w on both sides. Negative 1 equals w plus 37. Subtract 37 on both sides. W equals negative 38. Repeat. 4w, negative 5w. I'm going to move the negative 5w this time since it is smaller. Add 5w to both sides. 9w minus 1 equals negative 37. Add 1 to both sides. 9w equals negative 36. Finally, divide by 9. W equals negative 4. Now again, I'm going to check my work. W equals negative 38. That's what I'll do first. So again, we're plugging back into the original because that's where the split happened. 4 times negative 38 minus 1 equals 5 times negative 38 plus 37. 4 times negative 38 will give you a negative 152 minus 1. 5 times negative 38 will give you negative 190 plus 37. Absolute value, negative 152 minus 1 becomes negative 153. We still have those absolute value symbols. Equals negative 190 plus 37 gives me negative 153. And then a reminder, the absolute value of negative 153 makes it a positive. So our final thing here is we have 153, positive 153, equals negative 153. Which clearly does not work. So W equals negative 38 is not an answer. Now let's check it for our other value of W, negative 4. And I'm just going to go to a post-it note here, just because I don't want to run out of space for the next problem. W equals negative 4. So we have 4 times negative 4 minus 1 equals 5 times negative 4 plus 37. 4 times negative 4 is negative 16 minus 1 equals 5 times negative 4 is negative 20 plus 37. Negative 16 minus 1 is negative 17. Negative 20 plus 37 is positive 17. And lastly, the absolute value of negative 17 is still positive 17. And 17 equals 17. So actually, we do have one answer here. It is W equals negative 4. Number 6, our last absolute value equation before we move on to inequalities. This process is going to look very similar. The main difference between the two problems is, if you'll notice, they put the absolute value on the right side. Not a big deal here. So this is isolated right off the bat. Guess I should put it in view first. This is isolated right off the bat. And then we're going to make our two equations. First off, if you cannot stand having this on the right, you could flip-flop these. This is the same thing as the absolute value of 2x plus 4 equals 5x plus 8. Since it's an equal sign, you can put what's on the left on the right, and then what's on the right on the left. You can make them switch sides, like that. So, I'm going to go based off of that. So doing this, I'm going to drop the absolute values. I have 2x plus 4 equals 5x plus 8. Nothing changes. Just drop the absolute value. For the second equation, 2x plus 4 on the left. Now on the right, again, we make this negative, and we do that by changing both signs. Negative 5x minus 8. And then we solve. Reminder, if you need to take the extra step to put the negative in front of the original expression. Like that. That works too. Solving 2x plus 4 equals 5x plus 8. I'm going to move the 2x because it's smaller. 4 equals 3x plus 8. Subtract 8. 3x equals negative 4. And we are going to have a fraction. Divide by 3 on both sides. X equals negative 4/3. Repeat on the right. 2x and negative 5x. I will add 5x over. Bring down the negative 8. 2x and 5x, 7x plus 4. Subtract 4 on both sides. 7x equals negative 12. And another fraction. Divide by 7. X is equal to negative 12/7. Of course, we do have to check. We can't just assume that these work out as much as we'd love to because these are fractions. We still got to do it. And I'm probably going to run out of space here, so I'm just going to go ahead and get my post-it notes ready. So if x equals negative 4/3, this is my check. Reminder, we plug it back in to the original equation because that's where the split happened. So we have 5 times negative 4/3 plus 8 equals absolute value of 2 times negative 4/3 plus 4. 5 times negative 4/3 is negative 20/3 plus 8 equals, when you multiply, again, it's like 2 over 1. 2 times negative 4 is negative 8 over 3 plus 4. So now that I have all that plugged in, I can simplify it. I'm going to need to get some common denominators, though, because of the fractions. So 8 over 1, I'm going to multiply top and bottom by 3 so that I can get a 3 here, just like I need it here. So it gives me negative 20 over 3 plus 8 times 3 is 24 over 3 equals, same thing with the 4. And you multiply top and bottom by 3 so that I can add these together. So I have negative 8 over 3 plus 12 over 3. Negative 20 over 3 plus 24 over 3 is positive 4 over 3 equals negative 8 over 3 plus 12 over 3 is negative 4 over 3. And then finally, I have the absolute value of negative 4 over 3, which is going to give me positive 4 over 3. So I just have 4 over 3 equals 4 over 3. So our fraction here does work. So our answer of -4/3 does work. Now let's check -12/7. So checking. We have 5 times -12/7 plus 8 equals absolute value of 2 times -12/7 plus 4. And also, just a side note, I just noticed I did this. I plugged this back into the very original, like not the flipped version. It won't matter. Hopefully you knew that. All right, simplifying. If I just multiply these, I get -60/7 plus 8 equals absolute value -24/7 plus 4. And then I need common denominators. I'll put this over 1 and multiply by 7. That gives me -60/7 plus 56/7 equals. Same over here. I want common denominators. I have to multiply by 7 on top and bottom. So now I have -24/7 plus 7 times 4 is 28/7. And then -60 plus 56, that's a -4/7 equals absolute value. -24 plus 28, that's a +4/7. And lastly, we have to look at the absolute value itself. -4/7 equals, absolute value of 4/7 is still just 4/7. And as you can see, these are not equal. So, since they don't work, x equals -12/7 is not an answer. So I have one solution to this problem, and it is -4/3. So just a quick recap with these absolute value problems. You could have one answer, just like I did here. You can have two answers, or you could have no solution. Those are all the options for these types of problems. I'm going to remove the Post-it notes, and then we're going to move on to number 7. Now let's look at absolute value inequalities. There's a lot of similarities and differences between the inequalities and then the equalities, the equations that I just solved for you guys. So I do like these a little bit better just because the check does not take as long, and I enjoy the graphing part for some reason. Okay, so remember your hint. If the absolute value of A is less than B, then A is less than B and A is greater than -B. If the absolute value of A is greater than B, then A is greater than B, or A is less than -B. You don't have to be super good at the signs to get this. You can just compare your example to the hint to figure out which scenario you have. But I want to remind you of the mnemonic device we talked about in class. If you have less than, this is less than. Less than, meaning it's an and problem. And then if you have greater than, you have great or. So if it's a greater than, then it's an or problem. Side note, if you're watching this video and you are not one of my own students, I apologize. I teach the and statements just a little bit differently. This is how I prefer it as a student, and it just makes more sense. The compound inequality is still 100% correct. It's just another way to write your answer. Number 7, absolute value of -6r is greater than 30. So we're still going to follow the steps that I wrote out here. How they look in this problem is just a little bit different. So we have our inequality symbol, and I'm going to circle it just to create left side, right side. We see that our absolute value is by itself, as it should be. So now we can make our two equations. When we do this, there's an extra step here for the inequality. You have to ask yourself, and or. You have to figure out which scenario you have. This is greater than. Greater. Also, the sign matches up here. So I'm going to write it like this. So my A is my left side. I'm going to drop the absolute value. So I have negative 6R is greater than, B is just the number, 30. So it's the same thing, just no absolute values. Or A again, negative 6R is flip the sign less than, make your B negative, negative 30. From here we solve. Just one step for both of these. We need to divide off the negative 6. This cancels. We have R, 30 divided by negative 6 is negative 5. Something to note with inequalities, hopefully you remember this. The big rule you have to remember is if you divide or multiply by a negative number, you flip your inequality sign. So this is going to flip and be a less than. Or I divide by negative 6 over here, so I'm going to do the same thing. R is, flip this, greater than positive 5. So two negatives make a positive. So now I have R is less than negative 5 or R is greater than 5. Now let's do our check with our graph. I'm going to graph it. So I have negative 5 and 5, one positive, one negative, so 0 in the middle, 5 on the right, negative 5 on the left. There's no or equal to, so these are going to be open dots. For the 5, R is greater than, it's pointing to the right. So we're going to point this to the right. For negative 5, the symbol is pointing left, to the left. So we're going to draw our arrow to the left of negative 5. Hopefully you can see this is an OR graph because they're pointing away from each other. And that matches the type of statement we have. So I feel really confident about my answer. So I have, I'll just box it where it's at. It looks fine. R is less than negative 5 or R is greater than 5. Number 8. This one requires a little bit more work. So splitting this up into the left and right sides, I have 7 times the absolute value of x plus 5 minus 17 is less than 32. I need to isolate my absolute value first. Just a reminder. To do this, first thing I want to do is get rid of the constant. I'm going to add it over. This cancels, bring down 7 times the absolute value of x plus 5 is less than 49. Then we need to get rid of the 7. We're going to divide it off. Cancels. Absolute value of x plus 5 is less than 49 divided by 7 is just 49. 7, sorry. 49 divided by 7 is 7. And now you see that my absolute value is isolated. So now I can make my equations. Before I do this, I need to figure out which scenario I have. This is a less than symbol, so this is less than. So I'm going to write it this way. We have A, which is the absolute value of x plus 5, so it's just x plus 5, is less than, B is 7. So you're going to keep it normal, just drop the absolute values. And A again, x plus 5, is greater than, so we flip the sign, make your B negative. So this becomes negative 7. Now I can solve. Just one step each. To solve for x, I need to move the plus 5, so I'll subtract 5 on both sides. X is less than 2, 7 minus 5 is 2, and subtract 5 over here. X is greater than negative 12. Negative 7 minus 5 is negative 12. So last thing to do to check it is to graph it. I have 2 and negative 12. I've got one positive, one negative, so I'll put 0 in the middle. 2 goes on the right, negative 12 goes on the left. Again, there's no equal to under the symbols, so these are open circles again. X is less than 2, it's pointing to the left. So 2's arrow points left. X is greater than negative 12, points right. So negative 12's arrow points to the right. You can clearly see they overlap quite a bit. This is an AND graph, which matches our AND statement. Just a little reminder, if you want to use this trick of which way the symbol's pointing, your X, or whatever letter you're using, has to be on the left-hand side for that to work. Just a reminder. One more. Number 9, absolute value of x minus 11 over 3 is greater than or equal to 5. So again, first thing we need to do is isolate our absolute value. And I'm going to rewrite this to do that, just to more clearly show what I'm doing here. When your entire side of your equation is being divided by a number, the first thing you want to do is get rid of it, because I don't want this fraction. So since I'm dividing by 3, to get rid of the 3, all I have to do is multiply by 3 on both sides. Oops, almost forgot my absolute value. Okay, this cancels, and we have x minus 11 is greater than or equal to 15. 5 times 3 is 15. At this point, we are isolated. We don't have anything to remove from the absolute value. So now we can make our two equations. We need to figure out which scenario we have, and or. Let's check. Absolute value is greater than or equal to 15. Greater. This is or. So we're going to follow this here. A is just my stuff inside the absolute value. X minus 11 is greater than B, which is 15. And I have to use that equal to as well, since I have that in my problem. So if x minus 11 is greater than or equal to 15, I just drop the absolute value. Or, don't forget the or. X minus 11 is flip the sign, less than or equal to. Change the sign on the 15 to a negative. So then x minus 11 is less than or equal to negative 15. All right, let's solve. One step. Add 11 to both sides. X is greater than or equal to 26. Or, same thing over here. Add 11 to both sides. X is less than or equal to negative 4. Last thing to do is graph it and make sure that it's an OR graph. So I have a negative and a positive, 0 in the middle, positive on the right, negative on the left. For the 26, well, first off, these have the or equal to, so these are going to be closed circles. And then for the 26, x is pointing to the right, the symbol is, so we're going to move to the right. For negative 4, symbol's pointing left, so we are going to move to the left. They don't overlap, they don't touch, they don't come in close contact with each other. This is an OR statement, and it works. So, I have pretty good faith that my answer is correct. X is greater than or equal to 26, or x is less than or equal to negative 4. Next page. Piecewise functions. Evaluate the piecewise function. So we have different values of x here. Our piecewise function is g of x equals x plus 4 if x is less than negative 4. G of x equals 2x plus 5 if x is between negative 4 and 1, and that also includes those numbers. So x could also equal them as well. or g of x equals negative x plus 3 if x is bigger than 1, it's greater than 1. So let's use those to evaluate these different pieces. G of 6. So remember, this is like g of x. So when there's a number here, that means x equals that number. So it's telling us x equals 6. So you have to figure out where 6 fits in here. Start with the first one and work your way down. Is 6 less than negative 4? No. Is 6 between negative 4 and 1? No. Is 6 greater than 1? Yes. 6 is greater than 1. That's where it belongs. So we're going to use g of x equals negative x plus 3. G of 6, so we're going to plug it in now, equals negative 6 plus 3. G of 6 equals negative 6 plus 3 is negative 3. And if you want, you can put your final answer up top here so that it's separate from the work. All right. B, g of negative 5 halves. Here we have a fraction. X equals negative 5 halves. And I recommend converting this to a decimal at the very least so you can see what it is as a decimal. So as a decimal, negative 5 halves is negative 2.5. Reminder, you can easily do this in your calculator. All you have to do is divide negative 5 divided by 2. Negative 2.5. So now we know where it is on the number line. That helps. So now we're going to go figure out, is negative 2.5 less than negative 4? No, it's actually bigger than negative 4. Is negative 2.5 between negative 4 and 1? Absolutely. It's between these two. So we're going to use g of x equals 2x plus 5. Now, since this is a nice decimal, you could always just plug in the decimal and solve it that way. You'll probably want your calculator for that. I'm going to plug the fraction in because I know a lot of students prefer that. So let's plug in negative 5 halves. So we have 2 times negative 5 halves plus 5. Now again, this is just like multiplication over 1, so I'll write this as 2 over 1. If you multiply straight across, we get 2 times negative 5, which is negative 10 over 2. Negative 10 over 2 is negative 5, because negative 10 divided by 2 is negative 5. Plus 5. Negative 5 plus 5 is just 0. And that's it. G of 0, that means x equals 0. Go through and ask, is 0 less than negative 4? No. Is 0 between negative 4 and 1? Yes. So we're going to use this middle function here. So I'm going to use g of x equals 2x plus 5. G of 0 equals 2 times 0 plus 5. G of 0 equals 2 times 0 is 0. 0 plus 5 is 5. So g of 0 is 5. G of 1, x equals 1. Let's go through. Is 1 less than negative 4? Nope. Is 1 between negative 4 and 1? And that also includes 1 itself. Of course. It would fit in here. And it can't go in here because 1 is not bigger than itself. So once again, we're going to be using the middle function. G of x equals 2x plus 5. G of 1 equals 2 times 1 plus 5. G of 1 equals 2 times 1 is 2 plus 5. And finally, g of 1 will give us 7. One more. G of negative 12. X equals negative 12. Starting with the top one, is negative 12 less than negative 4? Yeah, very much so. So we're going to do g of x. This time we're using the top one. So we're using g of x equals x plus 4. Make sure you're carefully checking which one you're writing down. It's very easy to write down the wrong one. G of negative 12 equals negative 12 plus 4. G of negative 12 equals negative 12 plus 4 is just negative 8. So negative 8. That's number 10. Number 11, we're looking at graphs. If you skip the directions, you will not notice that it says to state the domain and range along with finding this information. I'm going to do some of this in pen. So, for domain, reminder domain is your x values, and we move from left to right. That's the direction. We'll start on the left side of the graph and work our way to the right. Now at first this looks like blank graph, but notice the first thing I hit is an arrow, so we want to back up and look at it again. Again, I understand that this arrow is pointing up, but right now we're just looking at left or right. We don't care about up or down. That's the range. So not only is it going up, it is moving in this direction. It is moving left. Slowly, but eventually, it's going to just keep going to the left. And reminder, when we keep going to the left or to the right, we have those infinities. To the left, we have negative infinity. To the right, we have positive infinity. If we go up, we have positive infinity. If we go down, we have negative infinity. So when it's moving to the left this way, it's pointing towards negative infinity. That's our starting part of the domain. So we're good. We're starting at negative infinity. We're hitting graph. We're going to follow it. At 0 on the x-axis, we have a hole here. However, it is filled in down here. So since we do have a 1 point that goes with that value, we can ignore the hole and keep going. So now it's straight, solid line. It's continuous. It's going to keep going, and we reach an arrow. And this arrow is going, yes, kind of up, but it is still going to the right. So it's going to keep going this way to the infinity symbol. So our domain is negative infinity to positive infinity. Now let's look at range. These are our y values. Range, oh, I forgot to mention, we go from B to T, bottom to top. Start at the bottom, work our way up. At the bottom of the graph, notice we don't have any line or points here. It's blank. So we're not going to start at negative infinity here. If we follow it upward, we see that our first point for a y value is this dot here at negative 1. So we're starting at negative 1. And since it's a solid dot, it's going to have a bracket. Reminder, I use parentheses in the domain because with the infinities, we always use parentheses. So for range, we're starting at negative 1. And then we're going to keep going upward. We have our continuous line here. When we get to the hole here at 1, it is a little bit concerning at first. But if I follow it, even though it's empty here, it's filled here by this line. So we can just ignore it and keep going. Following the line up, we reach these arrows at the top. They're going one's to the left and one's to the right, but they are both heading upward as well. Since they're both heading up, they are going towards infinity. So my range is negative 1 up to infinity. Value of f of 0. So this is something you can do on the graph. Sometimes it's easier on the graph because you're just looking for your answer instead of plugging something in. So this means that x equals 0. So you want to go to 0 on the x-axis, that is right here. I'll do this with pencil. 0 on the x-axis. And then you're going to go up and down till you find the value that goes with it. So there's a hole here. So this isn't going to be what f of 0 is. There's a point here. So when x is 0, y is negative 1. So essentially, you're looking for the point that connects to that value of x. And that's negative 1. Negative 1 connects to 0 on the x-axis. F of 4. That means that x equals 4. So you're going to go to 4 on the axis, on the x-axis, that's right here. Then you're going to go up and down until you find a value that goes with it. So notice, for 4, that connects to 3 on the y-axis. So 3 is my answer. 4, 3. It's just 3. Y-intercept. This is where the graph crosses the y-axis. The y-axis is through here. And it crosses it technically in 2 places. We have that hole here, but we don't count that since it's open. So we're going to go to the filled in circle. It crosses at negative 1. The proper way to write this is as a point. X is 0 on this point. And then 0, negative 1 on the y-axis. And that's that. Part B. We got to do domain and range again. Let's remind ourselves of the infinities. Left is negative infinity. Right is positive infinity. Up is positive infinity. Down is negative infinity. So domain, we go from left to right. We're going to start on the left side here with negative infinity. We're going to get onto the graph and notice this arrow here. Now again, we're looking only left to right. So we're going to see, is this moving to the left or to the right? This arrow is moving towards the left side, meaning that the graph does go further to the left than we can see. So it is going to head towards negative infinity as it moves left. So negative infinity is how I start my domain. So we got negative infinity. And then we have a hole here. Good news. If I connect these, if I go through here to find the nx value, it's a hole here, but it's filled in here. So it's like it cancels it out. So we're going to keep following the line. It's going straight. It's looking really, really good. And the line goes back down. And we have another arrow. Which direction is it going? We're looking at left or right, not up and down. It's going down, yes, but it's also going down to the right. So it's going to keep moving to the right. So eventually it's going to move that way towards infinity. So it's going to positive infinity. So it's negative infinity to positive infinity. Range. Range, we go from bottom to top. We look at the y's. So we're starting at the bottom. Notice I'm starting with 2 arrows here. They're both pointing downward, pointing down towards negative infinity. So that's the start of the range. Then I'm going to follow these lines. Here we are a little concerned about that because of the hole. But again, I'm testing y values, so I'm going horizontally. If I go horizontally here, I've got a hole here, but I got a line here, which means it's continuous and it's included on this line. It may not be included on this line, but that doesn't matter. It just has to be included at least in one place. So we're going to pretend that hole's not there. Keep going. Go on up. It is straight. It is continuous. It is solid until we end up at this point. This point is the top of the graph. After that, the graph is done. It does not go up any further. So this point is at 7. This is 7 on the graph. And that's for the y-axis, what we're looking at specifically. It goes up to 7, and we put a bracket around it since it is a solid point. So there's my domain and range. Now we evaluate g of negative 3. That means that x equals negative 3. So you find it on the axis. So it goes up by 2's. This is negative 2. This is negative 3. Now we're going to look up and down and find a point that connects with negative 3. This one here. Negative 3 connects to this point. This point is at 7. So when x is -3, the graph tells me that the answer is 7. And just to clarify, because this is the point -3, 7 on the graph. So when x is -3, g of x, or y, is 7. G of 1. That means x equals 1. So we're going to go on the graph and find 1 on the x-axis. That's halfway between the 0 and the 2. Now this one you're going to have to do a little bit of guesswork, because it's in the middle here. But if we go up and down, it connects here. So on the x-axis, this is at 1. And then on the y-axis, this is between 0 and 2. 0 and -2. It's a -2 there. It's between 0 and -2. So I'm going to call that -1. So this would be the point 1, -1. Y-intercept. We're looking for where the graph crosses the y-axis. So we're just going to go along the y-axis till we see part of the graph, part of the line. Right here, it cuts through the y-axis. And it's halfway between 0 and 2, so we're going to call that 1. And this is the point 0, 1. X is 0, y is 1. All right, number 12. Graph and describe the following features of the piecewise function. It's just another one of those that we just discussed here. Domain and range. So if we move from left to right on our graph, notice, let me back up here, can't forget our infinities. Negative infinity on the left, positive on the right. Up is positive, down is negative. Starting on the left side, we have an arrow coming out of the graph, and it's pointing, yes, it's pointing down, but it is slowly moving to the left because it's going to keep going this way, which is left on the x-axis. So we're going to call that negative infinity as our starting point. Let's follow the graph. We're going to move from left to right. I'm going to stop here because of this. Just a tad bit concerning. Now I have a hole here, but that x value is defined here. So I've got a filled in dot. So this cancels out the hole in the graph. So I'm going to keep going. Follow it some more. Straight, straight, straight. Looking good. Hit an arrow. It's going to keep going this direction. It's going to eventually go towards infinity on the x-axis. So this is negative infinity to positive infinity. Range, let's start at the bottom of the graph. Now this one's a little tricky because when we move upward, you might want to start at that hole, but notice I've got this arrow here. So this arrow is going to keep going, and it's going to go further, and it's going to go past where this hole is. So it's going to cover up the hole. You just can't see it. And then on top of that, it's going to keep going downward to negative infinity. So if we look at both graphs together, it starts at negative infinity. And when we do this domain and range, we're not looking at the graphs, the two lines separately, together, which values are covered by them. So if there are values covered by this graph that are left out by this one, namely here, that's fine. Together, we've got all of the values covered. So we're going to keep going up, following it's continuous, keep going. This graph stops here, but this one keeps going, so we're going to keep going. Keep going up, 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 and it goes to positive infinity as we move up. So negative infinity to positive infinity. Now let's evaluate f of 2 and f of negative 3. You can do this one of two ways. You can do it on the graph, or you can plug it in, like we've been doing. I'm going to do it on the graph just because we haven't had a ton of practice with this. And then if you want to plug it into the function by hand, go for it. You will get the exact same answer as I do. So f of 2, that means x equals 2. So we're going to go to 2 on the graph, 1, 2. And unfortunately, I actually cannot see that, so I'm going to have to use the function. Because if I go up, you can see it's getting there, but hasn't made it there yet, so I can't get a number. All right, let's ask ourselves the questions. Is 2 less than or equal to negative 3? No, it's bigger. Is 2 greater than negative 3? Yes. So we're going to use f of x equals 2x. F of plug in 2 equals 2 times 2. F of 2 equals 4. 2 times 2 is 4. 4. Negative 3. X equals negative 3. And I can use the graph for this one, so I'm going to. Negative 3 on the x-axis, we go left 3, 1, 2, 3. Negative 3 is right here. So I'm going to look up and down this for a y value. My x is here, what's my y? I've got a filled in point here and an open point here. Can't use the open point, so let's go to the filled in point. When x is negative 3, y is negative 1. Negative 1. So y is negative 1. If this helps, we're just connecting the two. Negative 1. If you don't like this, I will go ahead and show you with the function since I already did it the first time. Is negative 3 less than or equal to negative 3? So remember, that's our x value. Yes, it is. It's equal to it. So we use f of x equals x plus 2. So we plug in negative 3 for x. So we have f of negative 3 equals negative 3 plus 2. And negative 3 plus 2 is negative 1, which is what I got. So both ways work. Depends on which one works better for you. Y-intercept. Where does the graph cross the y-axis here? So I go up and down. I want to find a line that crosses. It crosses right here at the origin, so it crosses at 0, 0. Backside. If you made it this far in the video, I really appreciate it because this is definitely getting lengthier than I was hoping. Number 13. Graph and describe the following features of the piecewise function. It's another problem just like the one we just did. Domain. Mark our infinities. Negative infinity on the left, positive on the right, positive on top, negative on bottom. Domain, you start on the far right side of the graph, and we move from the left to the right to see which numbers we're hitting. We want to find graph and points. As soon as I get to the graph, I have this arrow. It's pointing, it's going to the left, it's moving left. So we're going to actually start at negative infinity. Since it just goes off the graph. So starting at negative infinity, we're going to move to the right. We've got a solid line. We're going to keep going here, stop here. Notice that when x is 1, we have two different things going on here. We have a hole, and then we have a filled in dot. This filled in dot is all I need to see. I can ignore the hole because if it's filled in, then I have a point here. So we're good. This cancels out the hole, and we're going to keep going. Follow it. This goes into an arrow. The arrow is moving in this direction. I understand it's pointing up, but it is going to move to the right as it moves further on. So it's going to move towards positive infinity. So our domain is just negative infinity to infinity. Range, we look at the y's, bottom to top. Starting at the bottom, as I go up, I hit an arrow that is heading downward. It's going to move this way, so it's heading towards negative infinity. So that's going to be my start for my range, is negative infinity. I'm going to move up, up, up on the y-axis. Here's an issue. We have a hole. And that hole is by itself. If I look from side to side to see if there are any other circled or filled in dots to save me here, I don't have any. We're stopping at this hole, unfortunately. So on the y-axis, this is negative 1, 2.5. Negative 2.5. And since this is an open circle, we're going to have a parenthesis here. Here's the problem. I'm not done with the graph because when I move up, there's a gap, but it continues up here. So remember, when you have a jump in the graph, you connect those together with a union symbol, the U. We're going to unite them with this union. So now with this union symbol, I can go up here until I hit the next point. And that looks like it is on 3. So we're going to start back up at 3. Since this is a filled in dot as opposed to open, filled in, we're going to put a bracket around this 3. And then let's see where it goes. Follow it up, it turns into an arrow pointing upward. It is going to infinity. Parenthesis for the infinity. So this is my range. Little wonky. Now we find the values f of 2 and f of negative 3. Again, how you go about this is up to the person if you want to plug it in or find it on the graph. F of 2. So this means x equals 2. So let me find a 2 on the graph. I kind of covered it up. 2 is right here. Once I find the 2, the number I'm looking for, I go up and down that line there looking for a y value to hit. It's completely blank down here for 2, but if I go up, I do have a point. When x is 2, y is 1, 2, 3, 4, 5. So when x is 2, y is 5. Again, if you prefer this way, by plugging it in, 2 is not greater than or equal to 1. My goodness, what am I saying? 2 is greater than or equal to 1. So we have f of x equals 2x plus 1. So we're going to plug 2 in for x. Two times 2 is 4, plus 1, that does equal 5, which is what I got up here. So, just to check my work, we are good. F of negative 3. Let's find that on the graph. So that, again, this means x is negative 3. So we go on the x-axis and we count over 3. And then let's go up and down till we find a y value, a point, a line. And right here we have something. We have 1, 2, 3, 4.5. And this is negative 4.5 since we went down. So where x is negative 3, y is negative 4.5. We can do this with the function. This might be one where you would actually prefer the graph, because if I use this, I already can tell you, I'm going to deal with this fraction here. So, I've already pointed it out. Here our value of x is negative 3, and negative 3 is less than 1. It's not greater than or equal to 1. So we're going to use f of x equals x over 2 minus 3. F of negative 3 equals negative 3 over 2 minus 3. That'll be negative 3 over 2 minus, I'm going to put this over 1 and multiply by 2 on top and bottom to get my fraction, negative 6 over 2, so I can subtract them. And negative 3 minus 6 is negative 9 over 2. Now if I divide that in my calculator, negative 9 over 2, I do get negative 4.5, which is what my original answer was. So these are the same thing. This is just a decimal, this is a fraction. So either way will work. Can't forget about the y-intercept, almost missed it. Y-intercept, where it crosses the y-axis, look up and down this y-axis, and we notice a point right here. That is at negative 3 on the y-axis. So our point is 0, negative 3. Number 14. Evaluate the following expressions. So they give us the values. A is -4, B is 5, X is -1, Y is -1/2. So whenever we have these letters, we're going to plug those in. So we have 7 times A plus 4 plus 3B minus 8. So we're going to plug all of that information in where we can. 7 times A is -4 plus 4 plus 3 parentheses times B is 5 minus 8. Remember your order of operations here. This is going to be extremely important. PEMDAS, please excuse my dear Aunt Sally. P, we start with parentheses. Looking through here, I've got this set of parentheses, so I need to do what's inside of it first. -4 plus 4 is 0, plus 3 times 5 minus 8. Parentheses, exponents, we don't have any exponents. Multiplication, we have multiplication in 2 spots, so I'm going to multiply both of these. 7 times 0 is 0, plus 3 times 5 is 15, minus 8. Now we've just got addition and subtraction left, so we just do them from left to right. 0 plus 15 is 15, minus 8 is 7. B, x over 4 plus y squared. X is -1, plus y is -1/2 squared. I'm going to do this part on a post-it note just because I don't have a ton of space. So we have an exponent here. We have to take care of that. -1/2 squared is the same thing as -1/2 times -1/2. We multiply two negatives, we get a positive, so this is going to be a positive number. And then you just multiply straight across. 1 times 1 is 1. 2 times 2 is 4. 1/4. So now I have -1/4 plus 1/4. -1/4 plus 1/4 is just 0. Number 15, solve. And don't get confused, I genuinely made this mistake myself when I made the key. We're not plugging x and y, just x. We're not plugging x in here. They actually want us to solve for x, so those letters were just for A and B. So let's solve. First things first, I've got parentheses in here. I have a number outside of those. I'm going to distribute that into these numbers. -3 times 4x is -12x. -3 times 3 is -9. 4 times 6x is 24x. 4 times 1 is 4. First things first, combine any like terms that you have. My x's, I have -12x and 24x. -12 and a positive 24 give me positive 12x. -9 and 4. -9 plus 4 leaves me with a -5 equals 43. Now I just solve for x. 2 steps. Step 1, move the constant, the 5. I have to add it over to cancel it out. Bring down the 12x. 43 plus 5 is 48. And then we need to divide off the 12. X is 4. All right, we have made it. Last problem, number 16. Graph the following linear equation. State the domain and range. So we have f of x equals -4x plus 5. Let me rewrite this in language you're more familiar with. Remember, f of x is the same thing as y. So I'm going to come up here real quick. Here, I never change this to y because of this notation here. It does not make sense to change it to y. However, when I'm graphing, I always rewrite this as y. It makes more sense to me. Y equals -4x plus 5. This should be familiar because this is y equals mx plus b form. Remember, B is for begin. B is your y-intercept. So we're going to begin at 5 on the y-axis. And then slope is how you move. Our slope is -4 over 1. It's rise over run. So since it's a -4, we're going to move down 4 and right 1. So let's follow that pattern. Down 4, right 1. Down 4, right 1. Down 4, right 1. Made enough points. Let's connect them together. You can use a ruler if you like. I'm just going to kind of sketch it. It doesn't have to be beautiful, as long as you get the point. Something like that. All right, domain and range. Believe it or not, this is probably the easiest domain and range problem that you have been given thus far. Because I've given you a bunch of different types, but nothing like this one. So, domain and range. This is going to look kind of weird when I use my method, but just work with me on this. When I move from left to right, it appears that I have no graph over here, but that's because I just haven't reached the arrow yet. So the first thing I hit is the arrow. This arrow, while moving up, is slanted towards the right. So it's going to move still to the right as it moves up. So it's moving, or sorry, to the left directions. It's moving up and left. It's going this way. So it's moving this way, slowly but surely. So for the domain, it's moving to the left. So negative infinity is the start. It's just going to keep going that way. I hit the arrow, I follow it. We've got a nice solid line here. It's headed straight down, but as it moves down, it is curving more and more to the right. So it's going to do this over time. It's just going to keep moving to the right slowly. So it's heading straight for infinity on the right. It's not heading straight down, so it's still moving over. Something to remember. Range. This one's going to be a bit more obvious. Start at the bottom, work your way up. We have an arrow pointing down to negative infinity. So we're going to start there. Get on the graph, follow it. We got a nice straight line, solid points, no holes, no jumps, no gaps. Just a nice line. We get to the top and we reach an arrow which is pointing up to positive infinity. So basically, when you have a nice straight line in y equals mx plus b form, your domain and range are both going to be negative infinity to positive infinity. Hopefully that makes sense. It really should, because there are no gaps, and when we have a line, it's just going to keep going. You know that. We can only graph so much of it here, but it's just going to keep going. All right, thank you for sticking with me through this video. I really appreciate it if you've made it this far. I hope this has been a good review for you. If you have any additional questions or anything like that, feel free to reach out to me via email. And then also you can come by my classroom, ask me at any point in time. I'll be happy to answer any questions you have. Otherwise, I hope you have an awesome day. Bye.